Good day everyone, my name is Carlin G. Arenas and we are the Group 1 and we'll be discussing steel design, bolted, riveted, and welded connections. Allowable strength design. For the net area of pinhole, we have F sub 1 is equals to 0.45 Fy, where Fy is equals to yield strength of steel. Next is the tensile stress. In tensile stress, we have yielding of cross section and fracture of the net section. For yielding of cross section, we have P is equal to 0.6 Fy Ag with factor of safety of 1.67, where Ag is equals to area gross. For fracture of net section, we have P is equal to 0.5 Fu Ae with factor of safety is equals to 2, and Fu is equals to ultimate tensile strength of steel. Code provision, diameter of hole is equals to diameter of fastener or rivets plus 1.6 mm. And the area net is equals or less than 85% of area gross. Next, you have shearing stress. And the shearing stress, meron tayong failure due to sliding. And ang formula dyan is P is equals to FVAV or P is equals to 0.3 FUAV. So FV equals sa allowable shearing stress, which is 0.3 FU. Kaya nagkaroon dito ng 0.3 FUAV. And yung AV naman equal siya sa area ng bolt multiply by the number of bolts. And that's for the single shear. Pag naman naging double shear, magiging multiply mo lang sa 2 yung number of bolts. And N is equal to number of fasteners or number of bolts. Note that FV is equals to shear stress on fasteners or rivets, not on steel plate. So, doon lang siya sa mga bolts, hindi sa steel plates. Next is bearing stress. Bearing stress, we have failure on projected area between the plate and the fastener and failure on steel plate. Formula is P is equals to FPAP and P is equals to 1.2 FUAP, where FP is equals to allowable bearing stress on steel plate equals din siya sa 1.2 FU, and AP is equals to summation of diameter of fastener multiplied by plate thickness. And last, we have combined shearing stress and tearing or block shear failure. And the formula is P is equals to FVAV plus FTAP. Situation number 1. A triple riveted butt joint has a long pitch of 200 mm and a short pitch of 100 mm. Diameter of rivet hole is 26.5 mm, thickness of main plate is 16 mm, and each cover plate is 12 mm. The joint carries a load of 200 kN and it is equally divided among the rivets. Assume diameter of rivet hole is the same as that of the rivet diameter. Number 1, compute the max shearing stress developed in riveted joints. Number 2, compute the max bearing stress developed in plates. Number 3, compute the max tensile stress developed in plates. So ngayon, proceed tayo sa solution. So makita natin sa kaliwa, meron tayo ditong figure and sinabi nga sa problem na ang 200,000 na load daw ay equally divided sa mga rivets. So ito yun, gawin natin siyang P1. So ang P1 equal siya sa 200,000 which is yung load over 12 which is yung number ng rivets. So P1 is equals to 16,666.67 Newton. Kalagay din dito na ang row 1 ay meron siyang 200,000 Newton na load. Which is yun yung resist niya na 200,000 Newton. Ito equivalent to ng lahat ng rivets. Dito naman sa row 2, syempre nabawasan na ng rivet sa side na to. Mababawasan siya ng 3. So kunin natin value ng load dito. So 200,000 minus 3, which is yung number ng rivets na wala dito sa part na to, multiply by 16,666.67, which is yung P1, equal siya sa 150,000 Newton. Sa row 3 naman, ganun din ulit. Bawasan naman siya ulit ng 4. So, 3 plus 4, 7 na yung minus natin. So, 200,000 minus 7 multiply by 16,666.67 equals naman siya sa 83,333.33 Newton. So, ngayon, proceed tayo sa stress. Dahil nakuha natin yung mga load niya, kuha natin yung stress kada row. So, ang stress is force over area. So, sigma 1 equal siya sa 200,000 over 500, which is yung haba nung plate, minus 3 multiply by 26.5. Ano yun? Yung 26.5, yun yung diameter ng rivets. Dahil sa row 1, nakita nyo naman, ayan, nakalagay, 3 rivets yun nandyan. So, 3 multiply by 26.5. Multiply by 16. Yung 16, yun yung thickness ng plate. So, ayan, ito na yung area sa baba. So, ang makukuha mo dyan is 29.73 megapascal. Ngayon, sa row 2 naman tayo, 150,000 Newton over 500 minus 4 multiply by 26.5. Kaya siya naging 4 kasi 4 yung rivets na sa row 2. And multiply natin yun sa 16, which is yung thickness ulit ng plate. Equal sa 23.79. Sa sigma 3, sa row 3 na tayo, 83,333.33 over 500 minus 5, kasi 5 na ulit yung nandun na rivets, multiply by 26.5 multiply by 16. Equal siya sa 14.17 megapascal. So, nakita natin, ang pinakamataas na value dyan is itong 29.73, which is nasa row 1. So, yan yung maximum na stress natin. Next. So, number 1, max shearing stress developed in riveted joints. So, kunin natin shearing stress sa rivet. So, kanina, kinumpit natin, nakuha natin na merong load ang kada rivets na, which is yung load P1. So, ang magiging formula natin yan is P1 over area ng rivets. So, 16,666.67 over pi over 4 multiply by 26.5 squared. Yung 26.5, yun yung diameter ng rivets. So, equal siya sa 30.22 megapascal. So, number 2, max bearing stress developed in plates. So, ganoon din ulit yun, force over area. 16,666.67 over 26.5 yung diameter ng rivet multiply by 16. Yung 16 yun yung thickness ng plate. Equal siya sa 39.31 megapascal. Number 3, max tensile stress developed in plates. So, para makuha natin max tensile stress, yan din yung nakumpit natin kanina na stress, which is yung pinakamataas lang sa kinumpit natin kanina nauna. Yun yung nasa row 1 na stress. So, equal siya sa 200,000 over 500 yung haba ng plate minus 3 multiply by 26.5, kasi ito yung rivets, minus natin yung rivets sa plates, multiply by 16 thickness ng plate. Equal siya sa 29.73 megapascal. So, yun yung maximum tensile stress. Next is situation number 2. A butt joint is bolted using A325 bolts with a diameter of 22 mm. With thread excluded from shear plane, allowable shear stress Ft is equals to 207 megapascal. Use A36 steel with yield strength Fy equals to 248 megapascal and the minimum tensile strength Fu is equals to 400 megapascal. Assume diameter of bolt hole to be 25 mm. So, number 1, compute the shear capacity of butt joint. Number 2, compute the bearing capacity of butt joint. Number 3, compute the block shear capacity of butt joint. Number 4, compute the efficiency of the butt joint. ngayon, proceed tayo sa solution. Nilist ko lang muna sa kaliwa dito yung mga given para madali natin makita. So number 1, shear capacity of butt joint. So gagamit na dito is yung allowable shear stress na FT. Equal siya sa force over area. So 207 equals to P, hinanap natin, over 9 pi over 4 multiply by 22 squared multiply by 2. So kaya ka nag-multiply ng 2 dito is dahil double shear siya. So P is equals to 1,416.374 kN. So number 2, bearing capacity of butt joint. So FP is equals to P over AP. Yung FP natin, di ba, equal siya sa 1.2 FU. So FU gagamit natin. So 1.2 multiply by 400 equals P over 9 multiply by 22 multiply by 22. Yung 22 na to is yung area ng yung diameter ng bolt natin multiply by thickness ng ating plate. So P is equals to 2090.88 kN. So para sa number 3, meron tayong block shear capacity. Meron tayo ditong apat na failure. Yung failure 1, 2, 3, 4. So sa failure 1, anong nangyari sa kanya? Galing dito sa kaliwa, kumanan, tapos bumaba. Tapos dito naman sa failure number 2, galing dito sa kaliwa, kumanan, bumaba, tapos bumalik. Tapos sa failure number 3, galing naman sa taas siya nagsimula. Tapos bumaba dito sa unang rivet, kumanan, tapos bumaba, diretso. Tapos sa failure number 4, bumaba siya dito sa unang rivet ulit sa kaliwa, tapos kumanan, tapos bumaba, tapos kumaliwa, saka bumaba ulit. So solve natin yan. So number 3, block shear capacity of butt joint. P is equals to ABFB plus ATFT. FB is equals 0.3 FU. So yung AB natin dito, siya yung dadaanan na effective area ng shear dito sa plates. So FB naman equals 0.3 FU. AT equals siya sa dadaanan ng shear na vertical. FT equals 0.5 FU. Failure 1, P is equals 0.3 multiply by 400, which is yung FU natin, multiply by 300, yun yung length na horizontal na dinaanan ng shear natin. Makita dito sa figure, bilangin nyo na lang 1, 2, 3 300 mula dito sa left side hanggang dito sa bolt ay sa hole. So minus 2.5 multiply by 25. So 2.5 kasi ang dinaanan niya is 2 butas at kalahati. Ang diameter naman ng hole is 25 mm. So multiply by 22, yun yung thickness niya. Plus 0.5 multiply by 400 multiply by 250. Ganun din sa vertical naman yun na dinaanan ng shear. Minus 2.5 multiply by 25 multiply by 22. So ang P natin dyan equals sa 1,452 kN. So next is failure number 2. So same lang dito na kanina na ibalik dinaanan ng pagkaka-shear. So P is equals 0.3 multiply by 400 multiply by 300 minus 2.5 multiply by 25 multiply by 22 multiply by 2. Kaya siya multiply ng 2 kasi kumanan siya tapos pagbaba niya bumalik. Diba? Ang nakalagay kasi dito is yung horizontal. So para hindi na mahaba, multiply na lang natin sa 2 yung magiging sagot dito. Plus 0.5 multiply by 400 multiply by 200 minus 2 multiply by 25 multiply by 22. P is equals to 1,914 kN. So next is dito sa failure 3. Failure 3, same lang din ako kanina. P is equals to 0.3 multiply by 400 multiply by 200 minus 2 multiply by 25 multiply by 22 plus 0.5 multiply by 400 multiply by 300 minus 3 multiply by 25 multiply by 22. So P is equals to 1,386 kilonewton. And for number 4, ganun din. Ulitin lang natin. P is equals 0.3 multiply by 400 multiply by 200 minus 2 multiply by 25 multiply by 22 times 2 kasi dalawang beses niyang same yung dinaanan niya. Plus 0.5 multiply by 400 multiply by 300 minus 3 multiply by 25 multiply by 22. So P is equals to 1,782 kilonewton. So take answer from failure 3 kasi yun yung pinakamababang value. So P is equals to 1,386 kilonewton. Ito na yung sagot sa number 3. And last, number 4, efficiency of the butt joint. So efficiency is equals to safe capacity over full strength multiply by 100%. So yung safe capacity natin ngayon ay nakuha natin na sa failure number 3, which is yung 1,386. Tapos yung full strength, ang formula sa kanya is 0.6 Fy multiply by area gross. So yung area na to is yung area ng plate, which is 300 by 22. So 1,386 kilonewton kasi to, multiply natin ng 1,000 para maging newton over 0.6 multiply by 248 yung Fy natin multiply by 300 mm multiply by 22 mm times 100%. So ang maging answer natin dyan is 141.13%. Thank you.